Hi everyone, my name is Rémi Casavet. I'm associate professor at the University of Lyon in France, and today I will present a paper called Data Compression to choose a proper dynamic network representation. So the objective of this paper is very simple. We often have data coming from social media or interaction between individuals, and we are interested in representing this data as a dynamic network evolving with time, but there are several ways to represent such a network, for instance with snapshots, with stream graph, temporal network, and so on and so forth. But there is not a proper way to choose which representation is the most appropriate for our data. To give a concrete example, here is some data coming from the sociopattern project, in which you can see that each row corresponds to one timestamp and a pair of nodes interacting during a particular second in time, and it's captured every 20 seconds. And you see that for this same data, there are several ways to represent it with dynamic networks. So the first one is snapshot. So you consider, for instance, that all interaction occurring during a particular second form a graph. Link stream, in which each row corresponds to one interaction, and interval graphs, in which you consider that if, for instance, two nodes are interacting every 20 seconds for a period of 1 hour, then you can represent this as an edge between these two nodes with a duration of 1 hour. The method we propose to choose a representation is based on the minimum description length principle, or the Occam razor. Basically, if you choose the most appropriate model to represent the data, then it should represent this data in a very efficient manner. So basically, we just count the number of bits required to encode some data with the formalism. So for instance, here you have a simple dynamic network, and you see that to encode it as a link stream, you need to cite the edge and then the times at which this edge appear. You see that there are also representation as matrices or as edge list, or even as, so as I explained before, an interval. So here it means that the edge AB exists over the period from T1 to T4. In this example. In this paper, what we propose is to make some experiments on synthetic networks and real networks, varying the aggregation window. So we check with no aggregation, or aggregating every hour, week, month, and so on and so forth. And we check what is the most efficient way to encode it at each aggregation level. So I don't have time, of course, to detail everything but you have to refer to the paper. But in this example, what is interesting is that we have taken the Enron email dataset, so email between employees of the Enron company. The original dataset is at the level of the minute, and we see that if we consider it as this level, the most efficient way to encode is by a link stream. And it's the same if we aggregate every hour, every day. But you see that if I move to aggregation every week or every month, then it's not as clear, and the interval graph representation might be the most efficient. And finally, if we aggregate every year, then we see that the aggregation, the snapshot representation becomes the most efficient. So it's really depending on the representation that you require, or the aggregation that you want to make to choose the proper representation. Another interesting example here is on sociopatterns, where we have taken two different datasets, one on high school and the other one concerning a hospital. But we see that actually the plots looks very, very similar, which means that there might be some intrinsic property of interactions captured this way. That makes that if you do not aggregate at all, then the interval graph is the most appropriate representation, then the link stream representation becomes the most efficient, and finally a snapshot representation. So in conclusion, the method we propose is a first quantitative approach to choose a proper representation of dynamic networks for a given dataset. There are many possible improvements that we want to explore, And if you have questions, I will be happy to answer these questions.